Here are a couple of examples of problems from section 3.4, particularly for anyone who wasn't in class on Tuesday when we went over these kinds of problems in class. The main thing is that we can evaluate piecewise functions by, for any given input, first considering which of the conditions on the right our input makes true, and then depending on which one it makes true, we use that part of the definition to produce the output. So for example, if I wanted to figure out what f of -1 is, I first think about the fact that this is my input, so this is my x, and I ask myself which of these two inequalities are true when x is -1. And I can see that the first one would say -1 is less than 0, which is true, and the second one says -1 greater than or equal to 0, which is false. We always have piecewise defined functions that are well defined, meaning that for any given x, that x is not going to fall in more than one of these. So we only have to find which one of these, for which one of these the inequality is true, and then we know that's the part to use. So in this case, -1 is less than 0, so this is true. So that means we use this definition to produce the output. So we're going to do 4 plus x for our x equals -1. So 4 plus -1 equals 3. And of course on the graph, this is an input-output pair, so when x is -1, y is 3. So I'll have a point at the point -1, comma 3. And so I can continue to plot some points this way. F of -2 is going to be 4 plus -2 for the same reason. So that's equal to +2. So when x is -2, y is +2. That's not so good. About there. And so if we plot a few points, we can see that we're going to have a straight line that that's going to go through those points and continue down to the left. Now, the fact that this condition ends at 0, 0 is a transition point between these two, and the definition ends at 0, but it ends by saying x is less than 0. So that's sort of like our idea of open interval, that our value of x has to be less than 0, but can get as close as we want to 0. And so the way that we illustrate that on our graph is we think about what this piece would look like at 0. So if x were equal to 0, then this would be 4 plus 0, or 4. But because x is only allowed to get very close to that and not equal to 0, I'm going to denote that on my graph by drawing a circle. And it's going to look like an open dot. That's not a very good picture, but it looks like an open circle at the point 0, 4. And so now I have the idea that my line looks like this. I'm just going to darken it in so I don't have to actually hit the points. And I have an open dot at the point 0, 4. So that's what the graph of this part of the function looks like. Now when we get to this part of the function, you can see I'm plotting a different kind of formula. So for example, if I had f of 1, or f of 2, or even f of 0, for all of those inputs, I would be using this second definition, because 1, 2, and 0 all make this inequality true. Realize that this is less than or equal to, so 0 less than or equal to 0 is a true statement. And so for each of those, I would do the algebra here to produce my output. So 1 squared is 1, 2 squared is 4, and 0 squared is 0. And that gives me 3 more input-output pairs. So I have a dot at 0, 0, a dot at 0, 1, and a dot at 2, 4. And I know that this kind of function is a parabola, so I expect this to have a parabolic shape. So I try to hit my points this way. Now notice that, sorry, that's kind of bad. Notice that at 0, 0, I have a solid dot, not a open dot like I did here, because 0 is included among these x's, and so 0 squared, as my output 0, 0, is actually included on that piece. So I have an open circle here because x equals 0 is not included, and I have a closed circle here because x equals 0 is included. And so that's what my graph looks like. The intercepts are fairly easy once we have a picture. The intercepts are just where the graph crosses either the x or the y-axis. Notice that at this point, this is not an intercept. The graph doesn't actually exist there. So the graph is definitely heading there, but it doesn't actually intercept. Point 0, 0 would be both an x and a y intercept. So among my x-intercepts, I would list 0, 0, and my y-intercept is also 0, 0. And then my other intercept is right here, this point right here. And if I don't know what point that is, which for my graph it's kind of hard to tell, remember that that I can find that by just figuring out where the y-coordinates equal to 0 for this piece. And so as long as I remember that this piece of the graph came from this algebra function, then I'm just solving the equation for plus x equal to 0. Where does that happen? It happens when x is negative 4. So at this point, negative 4, 0, I have another x-intercept. So my x-intercepts are there, and my y-intercept is also there. The two other questions here are find the range. Now the range is just remember all the y-coordinates that occur, and if you realize that these graphs continue, this piece continues down forever, this piece continues up forever, that means that the range is minus infinity to infinity. There's no place where the graph is, there's no value of x where we can't evaluate the graph, can't evaluate the function. We can see that just from here. Any x you give me is definitely going to make one of these things true, even if the x is like 1,000,000 or something. And so my domain is also minus infinity to infinity. And then finally, is the graph continuous? Well, we know from these pictures that continuity is something that we should really pay attention to at the transition point, and so we should specifically look at x equals 0, and we can see that it definitely is not continuous there. If you try to draw this picture, you would have to pick up, if you want to draw this picture, you would have to pick up your pencil when you got to x equals 0. So this graph is discontinuous. I certainly don't have room to write that. Discontinuous at x equals 0, for sure. So that's how we build our graph. Again, we want to plot points, which is basically just reading this notation correctly. And then we want to remember what the idea of domain, range, and intercept mean. And if we know what they mean, then it's problem to find them, especially if I already have some sketches to look at. In this problem, we're trying to find the definition that gives us the graph that looks like this. And so all we really have to do is identify that over on this side, that's a line, and over on this side, that's a line, and we know how to find the equation of lines. And so we'll just find the equation of those two lines separately, and then the piecewise part of the definition will tell us for which x's we use which definition. So it's pretty straightforward once we find those formulas for the lines. So the line on the left, since it goes through minus 1, 1 and 0, 0, we know the slope of the line over there is negative 1. That's just rise over run. We have rise of negative 1, run of 1, so there'll be negative 1 divided by 1 is negative 1. And it goes through the point 0, 0. And so if I use my point slope form, I'll come up with this as the equation of the line on the left, y equals negative x. If I follow the same kind of thing for the line on the right, the line's slope is 1/2. That's rise over run. It's really easy to do rise over run when one point is 0, 0. But the rise over run is just 1/2. And so my equation then is y equals 1/2 x. Again, it goes through 0, 0 and has slope 1/2. So that's the y equals 1/2 x is the equation of the line on the right. And so my function is going to be written like this. And I'll say I'll use the negative x formula, minus x formula, to get the y coordinate on the left side, and I'll use the 1/2 x formula to get the equation on the right side, and I'm going to use the left formula if x is between -1 and 0. And I'm going to include -1 and 0 because neither one of them on the graph has an open, empty circle. I'm going to use the piece on the right if 0 is less than x is less than 2. So for x is between 0 and 2, I'm going to use this formula. And again, there's no open circle, and so it doesn't matter. I mean, I can use less than or equal to, but there is one condition on piecewise defined function, and that is that it's unambiguous. And so because I included 0 in this range, I'm going to not include it in this range, so there's no ambiguity. It doesn't make any difference whether you switch these two symbols. Because this graph is continuous at this point, it's just changing direction. The y-coordinate of this line and the y-coordinate of this line are the same at the transition point. And so it doesn't make any difference whether that y-coordinate comes from this part or if that y-coordinate comes from this part. So we want to include it in one and not include it in the other, but because it's a point of continuity, it really doesn't matter in which area we include it. I think in the MyLabs Plus problems, it dictates what these inequalities are, so you have to do whichever way it wants you to enter it. But these will be the algebra formulas that are there.